Welcome back, and in this video I'm going to be showing you how we can use the Pythagorean identity to solve problems such as the one posed below, okay? And I kind of sometimes refer to this as coordinate trigonometry. I don't know if that's actually what it's called, but I feel like it's pretty fitting, okay? So they're saying if cosine of theta is 12 over 13, theta is in between 3 pi over 2 and 2 pi, then what is sine of theta? Now this is actually a very common problem. We see problems like this quite frequently, and if you've never done these before or seen how these are done before, then this is probably looking like gibberish, okay? But it's actually really not that complicated, okay? And I'm actually going to show you two different ways you can solve problems such as these. Because although it doesn't look like all this is vital information, everything they're giving you, there's no fluff to this problem, okay? Everything that is in this problem is needed to get the final answer, okay? First thing we can realize is that cosine of theta is 12 pi over 3. That's great, and we're trying to find sine. So I'm going to show you two ways you can solve this problem. The first way is by actually using one of the Pythagorean identities, and that is the one that sine squared of theta plus cosine squared of theta is equal to 1. Sorry, I keep hitting buttons on my pen and it's like screwing up my writing. Alright, so sine squared plus cosine is equal to 1. So I can actually substitute in this information. I don't know what sine is, but I do know that cosine is 12 over 13, so cosine squared is going to be 12 over 13 squared. Alright, and what I'm going to do is I'm going to solve this. We'll get to this part in just a second. This is going to help me find my final answer, but I'm going to go ahead and do this for just a moment, okay? So I'm going to simplify this. This is going to get me sine squared plus 12 over 13 squared is 144 over 169. And when I move over the 144 over 169, if I do 1 minus this, get a common denominator, and simplify if you can, this becomes 25 over 169. All I did is I subtracted 144 divided by 169 from 1. Okay. Now from here, we go ahead. We take the square root of each side. So I end up getting sine of theta, not sine of theta is equal to plus, remember, when you take the square root of each side, is plus or minus. Okay. And that's actually where this information comes into play. This looks like it's completely useless, but it's definitely not. Okay, what this is actually telling you is what quadrant theta's in. And depending on what quadrant theta's in, that's going to tell us if sine is actually positive or negative. So it's actually telling you if you should take the positive square root or the negative square root. Okay, and theta in between 3 pi over 2 and 2 pi, if you think back, that's quadrant 4. And in quadrant 4, sine is negative. So we actually get rid of the positive and only take the negative. So sine of theta is equal to negative, well, the square root of 25 is 5, the square root of 169 is 13, so sine of theta is negative 5 over 13. Okay, and that's the answer to our problem. Now that is a way using a Pythagorean identity, okay, and I actually personally I like never do it this way. Okay, the way I do it is actually just by using the Pythagorean theorem and my coordinate plane. The way I kind of like to think about these, we're going to get the exact same answer, just so you guys know. That wasn't straight enough for me. Neither is that, but whatever, we're going to go with it. I'm going to go ahead and draw a coordinate plane, and I'm just going to draw a triangle in quadrant 4. So I'm drawing a triangle, and I'm going to call the reference angle theta. Always use the reference angle. I've been talking how important reference angles are for, I can't even tell you how many videos now. Crazy important. Use the reference angle. Okay. And now I'm actually just going to go ahead and use that cosine is 12 over 13 to fill in this triangle. Well, cosine is adjacent over hypotenuse, so the adjacent side is 12, and the hypotenuse is 13. So I just fill those in, and now I can use the Pythagorean theorem to find this last side. So the missing side squared plus 12 squared is equal to 13 squared. So I get a squared is equal to 144 is equal to 169. A squared plus 144 is equal to 169. Subtract 144. Get a squared is equal to 25. A is plus or minus the square root of 25. Length can't be negative, so A is 5. I know I said the length can't be negative. So technically, this side here is 5. Okay, technically the side here is 5. Okay. Now, what I'm going to do is, because we're in quadrant 4, and this is the y value, notice this is the vertical component, and in quadrant 4, our vertical component y is negative. I'm just going to attach the negative to it. I know it's not actually negative 5. The length is positive 5, but I'm going to attach the negative to it so we can figure out what sine is without thinking about this anymore. Sine is opposite over hypotenuse. Negative 5 over 13. Okay, so that is really how we can solve problems like this. I'll go ahead and make up another one. Let me go ahead and make up another one. So let's say if, I don't know, I'm going to try to make this kind of a nice one, guys. You can deal with ones that have like radicals that you have to rationalize and stuff like that, but I'm going to trust that you guys can do that and don't need to see that. So I'm going to keep it nice Pythagorean triple. So I'm going to say if, let's say sine of theta is equal to 3 over 5. We're going to say theta is in between 0 degrees and 90 degrees. Then what is, let's say, tangent of theta. Now, once again, I'm going to do this both ways, okay? And right away, I'm going to go ahead and show that this is in quadrant 1, okay, where everything is positive. So notice I gave it to you in degrees in this problem. In the previous one, it was in radians. You need to be prepared for both, okay? So the first way, I'm going to use the Pythagorean identities, okay? And if I'm given sine, what I can do is go ahead and find cosine. Now, how is that going to help me find tangent? Well, because remember, tangent is sine over cosine. Okay, so what I can do is I can go ahead and use the Pythagorean identity, that is cosine squared plus sine squared is equal to 1, to find cosine, and then use sine and cosine to find tangent. So I'm going to go ahead and do that. So sine squared, well, sine is 3 over 5, so sine squared is 3 over 5 squared, plus cosine squared, I don't know what that is equal to 1. Well, that's going to become 9 over 25 plus cosine squared is equal to 1. Subtract 9 over 25 from each side. I'm going to get cosine squared is equal to 16 over 25. And this is where I take the square root of each side. And remember, this is where this information comes into play. I got to think about if it's the positive or the negative. Well, in quadrant 1, cosine is positive, so it's the positive. So cosine of theta is equal to positive square root of 16 over 5, or 16 over 25, which is 4 over 5. Okay, so now I can use the fact that tangent is sine over cosine. Sine over cosine. To simplify this, and the 5's would end up canceling, which would end up giving me tangent is 3 over 4. See, it becomes a little bit more difficult and complicated when your Pythagorean identity doesn't directly get you the answer. Okay, it still works, but I'm going to go ahead and kind of show my other way. Okay, this is in quadrant 1, so I'm just going to draw a triangle in quadrant 1. Always use the reference angle. And sine is opposite over hypotenuse, which means this is 3 over 5. And now I can go ahead and use the Pythagorean theorem to find that missing side. So the missing side squared plus 3 squared is equal to 5 squared. And this is going to become a squared is equal to 16. I'm going to leave you to do that work on your own. This gets me a is 4. I'm going to leave it as positive 4 because we're in quadrant 1 where everything's positive. This angle, if this was in quadrant 2, I would make that a -4. I know the length is a -4. I'm perfectly aware of that a length cannot be negative, but when we're doing trig in the coordinate plane, sometimes it's easier to just throw the negative on it so you get the right answer, okay? And now I can go ahead and find tangent fairly quickly, because tangent is opposite over adjacent, which is 3/4. So notice in both ways we get the same answer, okay? You might prefer the Pythagorean identity way. You might prefer this kind of Pythagorean theorem way with right triangles. It's entirely up to you. Just know that you can use both of these and you will always get the right answer as long as you do the right steps. All right, and that's how we can use a Pythagorean identity. Don't think that's the only way we can use it and be like, oh, that's stupid. I would never use it that way. Why do I learn it? Oh man, are we going to use it in many different ways in future videos, especially those of you that are in pre-calculus. But until then, have a good one and goodbye.